So, this is our golden box of knowledge for today. So, this works with every function, like every single one, which is nice. The A, we kind of talked about this the other day too, but like anything that's going on, that's happening to the X is going to affect it left and right. Because the X-axis is the left and right, the horizontal. Anything outside of this F value, like outside of plugging into the right X, is going to be happening to the Y. So like A, notice it's vertical stretch. If you're going to do like the actual general sine or cosine function, that's your amplitude. It's essentially how much you're going up and down. If it's negative or hot, if it's negative, it's reflected by the x-axis. Then this next guy, notice it's multiplication to the x value, like within f. That's like the same thing as this capital B in the second function. Like you didn't plug it into the capital T to the x, then you plug it into this line, so that's your horizontal stretch. If you're doing that for sine, that helps you figure out the period, which makes sense. Because the normal period is 0 to 5. Let's say you double that, that means that you're going to get the other ones are just like left and right, up and down. So this guy, the minus here, that's your horizontal shift. Horizontal shift, and this one's always like the opposite. It's minus C. You'll actually, if you take BC, you'll like know about that actually, why it's always minus, but it actually comes from but if it's minus C, you're going right, positive, left. The vertical shift, as far as describing the transformation, using the parent graph, like the classic parabola, describe the transformation obtained from the graph. Okay, so if it helps, it's already in standard form, but like this is like essentially your x squared, and then you got all these numbers going on with it, right? So if you're looking at this, you've got a number outside the parentheses, you got a 9. So if you look at your golden box of knowledge, that's your vertical stretch or shrink. So since it's a greater than 1, it's going to be a stretch. So you're going to think of this parabola as like pretty skinny. Vertical stretch. How did you guys say this would become factor or something? Okay. So in calc, you don't really need to explain any of this. They're just going to give you a function, and you just kind of have to go like know the vibe, okay, of what it looks like. So like for me, when I look at that, it's like parabola. I'm picturing something like really skinny. Okay, and that'll help you like solve for other things. Next thing is so the adding and subtracting, that's always going to be left. X is going to be left right. So then that means this one is always opposite. This guy, that's happening outside of what's happening to the x. So that's going to be going up and down. So that's what you can do. Part B is a parabola, so you still know that because it's got the x squared in it, but it's not like the normal way, like part A was. So you guys know what you're going to do. It's not factor.
With each love I could lose, I was never the same. Watching still living rooms be consumed by the flame. I was fixed on your hand of gold, laying waste to my loving long ago.
Done it plenty of times, I'm sure. Something.
It's not tonight.
Put it into standard form. How do you put a quadratic into standard form? If you're wrong, then it's correct. Complete the square. All right, ready, go. See if you remember. Complete the square. Ready, go. You can't forget anything you've ever learned. See if it'll come to you. I'll go through the whole thing, but see if you can remember. You got it. You should feel cool. Okay. So the way you complete the square is, what do I want to do? Green. You need to come up with this magical number so that this can be factored into that nice, pretty parenthesis square part. So that x plus c quantity squared, that's the goal. You want it to look cute. Okay? So what you're going to do, you have to get that magical number. The magical number is 6 divided by 2 squared. Okay? So it's always that b value on the x. So it's a coefficient on the x. You get 6 divided by 2, so squared is 9. But you have to be legal about it. You can't just be adding randos to an equation. You have to either add it to the other side, which is weird because h is over there, or subtract it from the same side. So what you're going to do now is this chunk can now be factored. Think about how that's factored, right? That isn't that x plus 3, right? So the way, the whole goal of this is, okay, here we go, is to make it look like that. So that highlighted part factors into that x plus 3, and then what's left over is just like your leftovers. So 7 minus 9. Okay. So this is your now standard form. Okay. So you complete the square, and then now we still didn't even answer the questions here. We have to explain what happened. So this one, it's happening to the x, so you're going to go left 3, down 2. Okay? Any questions? All right, next one. Find the linear function that corresponds to the graph. Okay, so I already have a y-intercept, so that's pretty nice. So what I'm going to need for a slope, because it's told linear, you could do a quick little slope formula. We're actually going to do another day on slope stuff. Or you could just do change in y, change in x, rise, run, whatever your vibe, okay? So if I do the change in y's over change of x's, we get negative 5 minus 2 all over. So I'm just taking the difference of y's over difference of x's, and we're left with, that would be plus 2, so negative 3. Then for the equation of a line, y equals mx plus b, we can go straight into that if we want. plug in the slope, and then plug in calc, they're more into point slope form. So if the other way you could have done it is you could have done like y minus 1, which we're actually going to have another way on that. So it would be y plus 2. Remember lines? Okay, now we got some absolute value graphs. So they have y equals absolute value x, and then you have to come up with a function for the red one and the blue one. So for f of x and g of x. So come up with a function for f of x and g of x. See if you can do it. I think you guys can. Okay, ready, go. Work with your people. The reveal. Okay, f of x, you're going right 3, up 2. Okay, g of x is reflected, so it is negative outside of absolute value. And you went left down. Alright, now the back. Okay, this is exactly what your matching quiz will look like. Okay, it'll be a rando graph. Okay, not a function that you know. Okay, and then you're going to have to match that graph with the other graphs of the two. So like you're going to figure out which graph corresponds to negative f of x. Which graph corresponds to f of negative x. So what you guys are going to do, maybe we'll give you like, I don't know, 8 minutes. You're going to go ahead and do all that. Okay, so this is your normal f of x. This is your normal f of x. And you have to figure out the transformation. So the parent graph is up on the right. So label each graph with its corresponding letter. Okay, so ready, go. Okay, so I tried to kind of explain them too a little bit.
Could ever try. So we just stood the hallway signs, a phantom and a fly. Follow lines and wonder why. There's no connection and rolling eyes and cheap shots from the tribe. And we're often new markers porch again. Another afternoon with the goat-head tunes and pilfered booze. We wandered through Mama's house, the milk from the window lights, family portraits circa 95. This is that foreign land with the sprayed on tans, and it all feels fine. Be a silk slide.
These guys, to kind of reason through this stuff, you have to label the different paths, you know? So, take some brain power I know a half outside messes with the amplitude because this looks kind of like a goofball sine cosine function maybe, but a little psychotic. So I know when there's a half outside of a sine function, it makes it shorter. So for me, on this one, I knew this had to be there's one half off of x, because the way I like my brain to visualize it is think about like the normal function it wouldn't go up as high. So I think that's where the half is. And then you have to think about what is that one half inside the x. That one like stretches out. So this one's gonna like stretch out the graph. So that one, maybe one that's like a little bit more spaced out horizontally. So f of x. So that's how I read it. So I think of it as like a graph. All right. This one's not really like wasn't a golden box, you know, where it like had all the negatives and numbers and things. But you can assume with an absolute value bar. So you can assume parts of the graph. So how can we construct the graph with any old function with absolute value bars? Put a graph there. So if I give you, I just gave you this one. So if I were to graph that parabola, right, it would be right here, and then, well, you guys know what it would be. Parabola. What's its transformation? Down 4, right? So it's a parabola down 4. So there you go. So you have -4, right? And then you have graph. Now, if I had to graph the absolute value, so this would be x minus 4. If I had to graph the absolute value of it, okay, think about what absolute values do. Okay? So think like absolute value of 4 is what? 4. Absolute value of 10. Then absolute value of -3. Positive, right? So all the negative, so like the positive ones are going to be fine. So like if I'm going to graph this, like all my positive chunks of the graph should be fine. Like this is positive y's, right? It's above the x-axis, like those are positive y coordinates. So like that's going to be the same. Because when you take the absolute value of a positive, it doesn't do anything. It just kind of stays. But then what happens in this chunk is weird. Because like what's going to happen to that? Yeah, it's reflected over the x-axis. Because think about it, there's negative and positive. So what you can conclude, even though it's not like a straight up rule, okay, for absolute value graphs, you can say like positive values stay the same. And then negative
with everything that you held dear. But you shed not a single tear for the things that you didn't need.
So even though it's not like a transformation text style, if they put bars around